All right, so if you take a look at number 1 on the review sheet, they just want us to solve for x. Now, first of all, I want to point out, I don't know what this graph is. I don't even know how it got onto onto my review sheet here, but you shouldn't see this on your paper. Okay, this is all you should see. All right, so in solving a radical equation, the first thing we want to do is we want to isolate the radical. So what that means is we want to get this radical all by itself on one side of the equation. All right, so in order to do that, I'm going to subtract the 9x from both sides of the equation. Okay, so the 9x minus 9x cancels, and I can bring down that radical. And then on the right-hand side of the equation, we're just going to combine the like terms. So 7x minus 9x would be negative 2x. And I'm going to bring down the plus 7. Okay, so we're on to step number 2. Now, step number 2. Once we have the radical all by itself, what we're going to do is we're going to square both sides of the equation. Okay, so I'm going to put both sides of the equation in parentheses, and we're going to square it. Now, the reason we do that is because a square and a square root cancel each other out, so what we're left with is just what was underneath the radical. Okay, so 54 minus 21x minus 2x squared. And then on the right-hand side of the equation, okay, don't be tricked. Don't think you could take this square, and distribute it onto both terms. If we have a binomial being squared, what it means is we have 2 of them. So we're going to take this, negative 2x plus 7, and we're going to write it out twice. Okay, so the left-hand side of the equation I'm just going to bring down for right now. Okay, I'm not going to really do anything with that. But the right-hand side of the equation, I'm going to double distribute. So negative 2x times negative 2x is positive 4x squared. Negative 2x times 7 is negative 14x. 7 times negative 2x is negative 14x. And 7 times 7 is 49. Okay, now I know I need to combine my like terms, but I also have to get one side of the equation set equal to 0, and I kind of like to do that all in one step. Now, when deciding which way to move my terms, here we have a negative 2x squared, and here we have a positive 4x squared. Okay, I'm looking at my terms with the biggest exponent. And since positive 4 is bigger than negative 2, I'm going to bring my terms to the side with the bigger leading coefficient. Because by doing so, by bringing everything else over to this side, it'll leave us with a positive number in front of our x squared term. Okay, so I'm going to get rid of the 54, I'm going to subtract it. And I have to do that to the other side as well, and I'll line it up underneath the other number because those are like terms. Okay, to get rid of the negative 21x, I'm going to have to add it. And I'm going to line that up under my 2 terms that are like with it, right, my 2 other terms that contain x's. And then I'm going to add the 2x squared. And I'll line that up under the 4x squared. Okay, I'm lining up my like terms. So on the left-hand side of the equation, everything cancels. And on the right-hand side, 4x squared plus 2x squared is 6x squared. And then when I combine negative 14x, and positive 21x, well, negative 14 minus 14 is negative 28. And negative 28 plus 21 would be negative 7. So that'll give me minus 7x. And then finally, 49 minus 54 is negative 5. Okay, now we're just going to solve. So you can either use the quadratic formula, or you could factor and make a t-chart. I'm going to go about it by factoring. Right, let me give myself a little more room. So because the number in front of the first term is something other than 1, we know we're going to need to do the rainbow. So with the rainbow, we connect the first and last numbers and we multiply those, which gives us negative 30. So we have to come up with 2 numbers that multiply to negative 30 and add to negative 7. Now, before we do that, actually, I'm going to just kind of organize myself. I'm going to bring down the first term. I'm going to leave a big space, and I'm going to bring down the last term. Okay, so now, like we were saying, we have to come up with 2 numbers that multiply to negative 30, and they're going to add to negative 7. All right, so that would be what? Negative 10 and positive 3? Okay, so I'm going to put actually the positive 3 first, along with an x, because if this middle term contains an x, we need to put an x here. And then I'm going to put the negative 10 along with an x as well. Okay, so bring down the 0 equals, right? Make sure you have 0 equals in every single step, and then just group. So here we could pull out a 3x, which leaves us with 2x plus 1. And actually, out of the next two terms, we're going to need to pull out a negative 5 in order to be left with the 2x plus 1 in parentheses, right? Because negative 10x divided by negative 5 is positive 2x. And then negative 5 divided by negative 5 is positive 1. Okay, and then again, keep it in equation, so make sure you write 0 equals. And then you can group together the 3x and the minus 5 in the first parenthesis. And you can rewrite the common binomial of 2x plus 1 in the other. All right, and let's just make a t-chart and solve. Now, I know a lot of you guys are at the point where you kind of get the trick. If you want to, without showing all your work, you could see on this side, you would wind up with x equals positive 5 over 3. Whereas on this side, you'd wind up with x equals negative 1 over 2. If you can't look at it and do it like that, no big deal. Just set each of these factors equal to 0. And then just solve these equations. Okay, so when we solve the first one, we would add 5. And then to get the x by itself, we would divide by 3. So that gives us x equals 5/3. And then over here, we would subtract 1. Okay, which leaves us with 2x equals negative 1. And then when we divide by 2, we get x equals negative 1/2. Okay, now it's so important to check because remember, extraneous roots occur here, okay? Sometimes you'll solve everything correctly, but it may not check in the original equation. All right, so this is what we do. All right, so what I did was in the calculator, I started over here with the 5/3, okay? In the calculator, I did 5/3 store x. Then I plugged in the left-hand side of the equation, and it gave me some decimals, so I just said, let me make it an exact answer. I hit math, enter, enter, and changed it to a fraction. Then I plugged in the right-hand side of the equation, and look at that, it gave me the same fraction. So what that means is that 5/3 is an answer. Okay, so now over here, I checked the negative 1/2. So I just used negative 0.5, it's the same thing, store as x. And I plugged in the left-hand side of the equation, and I wound up getting 3.5. And then I plugged in the right-hand side of the equation, and I also got 3.5. So that means this is a solution as well. So sometimes both of your values would check. Sometimes, one of them will, the other one won't. And, if that happens, you want to cross off the solution that doesn't work and just write extraneous root. All right, so in number 2, we again have a radical equation. So the first thing we want to do is we want to isolate the radical. So I'm going to subtract 6. Actually, let me just make this a little bigger. Okay, so I'm going to subtract 6 from both sides of the equation. And that'll leave me with 2a minus 6 equals the square root of negative 3a plus 54. Okay, so now that we have the square root by itself, we know that a square and a square root cancel each other out, right? So I'm going to square both sides of the equation. Now on the left-hand side of the equation, if we have a binomial being squared, please don't try to distribute the square in, right? It means we have 2 of these binomials. So let's write it out twice. And then on the left side of the equation, a square and a square root cancel each other out. That's why we, squared both sides of the equation. So we're left with what's underneath the radical. All right, now what we have to do is solve. So in order to solve this, on the left-hand side of the equation, we're going to double distribute. So 2a times 2a is 4a squared. And then 2a times negative 6 is negative 12a. Then negative 6 times 2a is another negative 12a. And negative 6 times negative 6 is positive 36. And I'll bring down the right-hand side of the equation. Okay, so we have two things we have to do now. We have to combine our like terms, and since we have a square within our equation, we want to get one side of the equation set equal to 0. So since I have my a squared on the left-hand side of the equation and it's already positive, I'm going to move everything to the left. So I'm going to add 3a to both sides of the equation. I'll line that up underneath my a terms. And then I'm going to subtract 54 from both sides of the equation, and I'll line that up under the number. All right, so on the right-hand side of the equation, everything cancels, so we're left with 0. And on the left-hand side of the equation, the 4a squared comes down. When I combine negative 12a, and positive 3a, that'll give me negative 21a. And then 36 minus 54 would be negative 18. All right, so from here it's up to you if you prefer to factor and make a t-chart or use the quadratic formula. All right, I'm going to factor. So because I have a number other than 1 in front of my first term, I know I have to do the rainbow. So I'm going to bring down my first term, leave a big space, and bring down my last term. Just make that minus sign a little better. And then I have to come up with two numbers that multiply to negative 72, right, our rainbow number, and then add to negative 21. All right, so let's see. Two numbers that multiply to negative 72 and add to negative 21 would be negative 24 and positive 3. So I'm going to write negative 24. And don't forget about the a, right? If this term has an a, we need to put it there. And then positive 3a. Okay, so now that we have our four terms, let's group. And out of the first two terms, we could pull out a 4a, which leaves us with a minus 6. And out of the last two terms, we could pull out a positive 3, which also leaves us with a minus 6. And don't forget to bring down that equals 0, right? You have to keep it in an equation the whole way through. So that means you have to have an equal sign until you're done. All right, so now I'm going to group together the 4a and the plus 3. And I'm going to rewrite the a minus 6 just once. And from here, we can make our t-chart. All right, it's up to you if you want to show work. You can just write out the answers, right? Here we would get negative 3 over 4, whereas here we would get positive 6. But if you want to set each factor equal to 0 and show how we're getting that, that's up to you. Okay, so I'm going to subtract 3 from both sides of the equation. So that gives me 4a equals negative 3. And then when I divide by 4, it's going to give me a equals, you could write negative 3/4, or if you want to write it as a decimal, I'm okay with that because it's negative 0.75. It's a decimal that stops, a decimal that terminates. So that's up to you. Okay, then on this side of the equation, I know most of you guys don't show work for this. You just get a equals 6. Okay, now remember, you have to check to make sure that we don't have any extraneous roots. All right, so what I did was I checked this value first, okay? I did negative 3/4, store as x. And then I took the left-hand side of the equation and plugged that in my calculator, except I use an x instead of an a. And then I plugged the right-hand side of the equation in to my calculator, and look, these don't match up. So what that tells me is that a equals negative 3/4 is an extraneous root. Okay, that one doesn't check. Okay, now we have to check the other value, okay, of 6. So I did the same thing. I did 6 store x. I plugged in the left-hand side of the equation, hit enter. I plugged in the right-hand side of the equation, hit enter. And look at that, they match up. So that tells us that a equals 6 is a solution. And one thing I want to point out, you always have to check in the original equation, okay? Don't go back and check here because it will check out there, okay? These are the two answers to this equation. You want to go back and check in the original radical equation. Okay, so number 3 is multiple choice. With multiple choice, I don't even want you solving this by hand. I just want you to take the answer choices and plug them in and see what checks. All right, so let's start with choice 1. Choice 1 has a 3 as well as a 12 in the solution set. So let's store x as 3 in our calculator and see if that checks out. Okay, so that's what I did. I did 3 store x. Now here, I didn't have to plug in both sides of the equation. I just plugged in the left-hand side of the equation and hit enter. And look at that, this does equal the right side of the equation. So when you substitute in 3 checks. So it's either got to be choice 1 or choice 2. Okay, we can automatically eliminate these because they don't contain a 3. All right, so let's see if 12 checks. All right, so I did the same thing. I did 12 store x. And then when I plugged in the left-hand side of the equation and hit enter, it gave me 3. And the right-hand side of the equation does equal 3. So 12 checks as well, so that tells me that choice 1 is my answer. All right, number 4. We've seen this question before. I remember this one from the packet. All right, there's a couple different ways that you could start this. I mean, you could take this exponent on the outside and you can basically kind of like raise each individual term within the parentheses to the negative 1/2 power. But honestly, what I think is easier is if we start within the parentheses, okay? If we're dividing 2 terms with the same base, right? They both have a base of an x. All you do is subtract these exponents. All right, so I'm going to, I mean, you could do this in your calculator. I prefer for you to, try it by hand. But if I do 2 minus 1/3, so 2 over 1 minus 1 over 3, I just have to find a common denominator. So if I multiply the first denominator by 3, then check that out. Both denominators will be 3. So there's my common denominator. But if I multiply this denominator by 3, I have to multiply the numerator by 3 as well to keep it equivalent. Okay? So then we have 6 over 3 minus 1 over 3. All right, and then since 6 minus 1 is 5, that leaves us with 5/3. Okay, so I'm going to rewrite this. I'm just going to write equals. Inside the parentheses, we have x to the 5/3 power. Okay, and then I'm going to bring over that negative 1/2. Okay, so now from here, if we have a power raised to another power, don't we just multiply these? Okay, so let's do that. So that'll leave us with x to the, well, when you multiply fractions, you just multiply the numerators and multiply the denominators. So first of all, a positive times a negative is a negative. And then 5 times 1 is 5. And 3 times 2 is 6. All right, now, negative exponent. We don't like negative exponents, right? So if we have a negative exponent, let's make this into a fraction by putting it over 1. And then we know to make an exponent positive, you take that term that's being raised to the negative exponent and you move it to the other side of the fraction bar. So since this is in the numerator, if we take this and move it down to the denominator, the exponent becomes positive. And then we do need a placeholder on the top. So that 1 that was in front of that x is going to stay there in the numerator. All right, now if we look at the answer choices, you see here that everything is in radical form. So to switch from exponential form to radical form, we use power over root. Okay, so I'm going to rewrite this as 1 over. So since this is the root and this is the power, to be the 6th root of x to the 5th power. Okay, and if we look, that matches up with choice 2. All right, if we take a look at number 5, they want to know which equation is false. Okay, so I'm going to start with the first one. The first one says that x to the 3/2 power squared is equal to the right-hand side of the equation. All right, well, we know when we have a power raised to another power, we have to multiply the exponents. All right, so I'm going to write this as, let me make this bigger so it's easier for me to write on. There we go. Okay, so I'm going to make this 2 into a 2 over 1. That way, these are both fractions when we go to multiply them. Okay, so I'm going to keep my base of x. Let's do choice 1 down here. I'm going to keep my base of x. And then here, if I do 3 halves times 2 over 1, that would give me 6 over 2. And doesn't 6 over 2, right? 6 divided by 2 is just 3. This simplifies to x to the 3rd power. Now, this side of the equation doesn't say x to the 3rd. It says the 4th root of x to the 3rd. So I'm assuming right away, this is my false one. Okay, these don't match up. But I'm going to try the other answer choices just to make sure. It's always important to try everything else out. Okay, so choice number 2. Now again, here we have a power being raised to another power. So let me just put this 3 over 1. And when you have a power raised to another power, you multiply the exponents. So this will give me x to the 3/4 power. All right, now, since this is written in radical form, we know if we have a fractional exponent, we can rewrite this in radical form using power over root. So it'd be the 4th root of x to the 3rd power. And if we look at the answer choice, look at the right-hand side of the equation, look, those match up. So this is true. So choice 2 is out. All right, let's look at number 3. We're doing the same thing for all these. We have a power raised to another power. So when I multiply the exponents, right, I keep the base of an x, and when I multiply the exponents, I get 3 over 4, which actually is the same exact thing as the last one, right? Look at that. X to the 3/4. So I'm just going to take this and bring it over, right? If we do power over root, we know it's the 4th root of x to the 3rd power, which is what this says. Okay, so choice number 3 is true. So we'll cross that one off. And then finally, number 4. All right, again, I'm going to make this into a fraction by putting it over 1. And when we have a power raised to another power, we multiply. So here we're going to have x to the 4/3. And if we write, since we have a fractional exponent, right, a rational exponent, we could rewrite that in radical form. It would be the cube root of x to the 4th power. So the cube root of x to the 4th power, which is what this says. So choice 4 is also a true statement. And so we were right from the beginning. Choice 1 is the answer. Okay, so number 6 wants us to take this expression and write it as a single term with a rational exponent. So that means your exponent is going to be a fraction. That's what a rational is. It's a fractional exponent. All right, so let's start with the numerator. Here we have a power being raised to another power. Now we know when we have that, we have to multiply the exponents. So I'm going to take this 4 and put it over 1. And then basically you're just going to do, 4 over 1 times 2 over 3. So 4 times 2 is 8, and 1 times 3 is 3. So this will be b to the 8/3. All right, so in the numerator, we have b to the 8/3. Okay, in the denominator, I'm going to use my power over root rule. So since the power is 5 and the root is 4, I could rewrite this as b to the 5/4 power. Okay, it's power over root. So 5 is the power and 4 is the root. All right, so from here, we're actually almost done. If we're dividing two terms with the same base, we just have to subtract these exponents. All right, so I'm going to do that off to the side. So if I have 8/3 and I want to subtract 5/4, well, I want to find a common denominator. So if I list out the multiples of 3, right, 3, 6, 9, 12, 15, and so on, and if I list out the multiples of 4, 4, 8, 12, 16, and so on, the lowest number they have in common is 12. So I can make this 3 into a 12 by multiplying it by 4. But if I multiply the denominator by 4, I have to do that to the numerator. All right, so that'll leave me with, that's a 4 by the way, it kind of looks like a 9. That'll leave me with 32 over 12. And then I'll bring down my minus sign. And if I want to make this 4 into a 12, I'll multiply it by 3. And if I multiply the denominator by 3, I have to multiply the numerator by 3. So that'll leave me with 15 over 12. And then when I subtract these, right, you subtract the numerators and keep the denominator, it's going to leave me with, well, 32 minus 15 is 17. So it's going to leave me with 17/12. So I can come back over here and remember, when you divide two terms with the same base, you keep the base. So I'm going to keep the base of b. And when I subtract the exponents, I got 17/12. So there's my rational exponent or my fractional exponent. So b to the 17/12. All right, let's see what number 7 says. Number 7, okay, it says, is this expression equivalent to this expression? And then over here it says to justify your answer, so that just means show your work. If it said explain, you'd have to write in words, but justify just means show your work. All right, so let's take a look at this. There's kind of a lot going on in here, so let's just take a look at it one step at a time. Now, here we have a parenthesis being raised to the 8th power. So I'm first going to start, and I'm going to basically raise the p squared to the 8th power, and I'm going to raise the n to the 1/2 to the 8th power. So you can think about it as you're taking this exponent and distributing it onto both terms. So when you have a power raised to another power, you multiply. So since 2 times 8 is 16, I'm going to rewrite this as p to the 16th. I'll put this in parentheses. And then 1/2, half of 8 is 4. Or if you want to think about it like, let's put this 8 over 1. 1 times 8 is 8, and 2 times 1 is 2. So we get 8 over 2, which simplifies. 8 divided by 2 is 4. So we can rewrite this as n to the 4th. All right, now I'm going to try to take this out of radical form. Now this is a square root. There's not a number right here, but if you want to think about it as a number being there, technically there's a little 2 in there, right? That's what a square root means. So if we use power over root, okay, this is the square root of p to the 5th power. So 5 is the power and 2 is the root. So I could rewrite this as p to the 5/2. I'm just going to put it in a parenthesis, I guess. So p to the power of 5 divided by the root of 2. All right, so same thing here. Now we have an n to the 4th power. So if we want to do this, it's really the square root of n to the 4th power. If I want to do power over root, I'll have n to the 4/2 power. So n to the power over root. Now, think about this. What's 4 divided by 2? 4 divided by 2 is just 2. So I'm actually going to erase this and just make it a 2. So that's n squared. Okay, so now, if we're multiplying, right, let's start with the p's. If we multiply two terms with the same base, we have to add the exponents. So I'm going to keep the base of p, and off to the side, I'm going to add these exponents. I'm going to add 16 and 5/2. So, oop, thought it was on my pen. So 16, I'm going to make that over 1, make it into a fraction, right, plus 5/2. So if I want to find a common denominator, I'll multiply the first fraction by 2 over 2. That way they both have a denominator of 2. And this will leave me with 32 over 2. And then plus 5 over 2. Okay, so then that's equal to, just add the top and keep the bottom. So 37 over 2. All right, so I'm going to write this as p to the 37 halves. Okay, now let's look at the ends. N to the 4th times n squared. You just add the exponents. So that'll give me n to the 6th power. Let me just put equal signs in front of all these. All right, now we want to know, is this equivalent to this? Well, this has a radical in the answer. So, well, actually, look, here's an n to the 6th, and here's an n to the 6th. So the n matches up. Now, since the p has some p's out of the radical and some p's under the radical, let's change this p into radical form. So if we do power over root, this would be the square root of p to the 37th power. So the square root of p to the 37th power. And then I'm just going to bring down, I'll just put the multiplication symbol, this n to the 6th power. If you don't want to use the multiplication symbol, you could just take this and bring it right to the front. All right, now, it looks like here what they did was they simplified this radical. Remember, if an exponent is an even number, then the term that it's on is a perfect square. So p to the 37th is not a perfect square because 37 is not an even number. So what I'm going to do is I'm going to take this radical and I'm going to break it up into two separate radicals. This is where I'm going to put my perfect squares, and this is where I'm going to put my leftover. Now the biggest perfect square that divides evenly into p to the 37th is p to the 36, right? Because isn't 36 the biggest even number? That's less than 37. So I'm going to write p to the 36 here, and that would leave me with 1p left over. And for right now, again, I'll just bring down my n to the 6th. Okay, so the square root of p to the 36, if you remember, when you take the square root of something with an exponent, you just cut that number in half. Or if you want to think about it, if we do power divided by root, isn't the root really a 2? So 36 divided by 2 is 18. So this simplifies, since it's a perfect square, it comes out of the square root, and it simplifies to p to the 18th power. And then what I'm going to do is, I'm actually going to take this n to the 6 and bring it in front of the radical, right? So I'm going to take the n to the 6th and put it right next to the p to the 18th. And the reason I'm doing that is because I'm on my last step. I want to have this radical at the end of the expression. So it gives me radical p. So now let's look. What I have right here actually is exactly what I have right there. So I can say that yes, this original expression is equivalent to this expression. Okay, so there we go. And I would box this off because this is the final answer. Okay, this is your work and this is your final answer. Okay, so number 8 asks us to take this expression and express it in a plus bi form. All right, now, we know when something is cubed, it means that there's 3 of them. So let's take it and write it out 3 times. You're only going to multiply 2 of the parentheses together first, and then you'll take that answer and multiply it by the third. So it's up to you. I mean, you could multiply these 2 together first. You can multiply these 2 together first. It totally doesn't matter. I'm going to multiply these last 2 together. I'm just going to keep bringing this down for right now. So I'll bring down the first parenthesis. And then when I double distribute the next pair of parentheses, I get, well, 1 times 1 is 1. 1 times negative 2i would be negative 2i. Negative 2i times 1 is negative 2i. And negative 2i times negative 2i would be, well, a negative times a negative is a positive. 2 times 2 is 4. And I times I is I squared. Okay, so I'm going to bring down this first parenthesis. Oh, look at that. I wrote it wrong before. I didn't even realize that. All right, let me change this. Right, that was supposed to be a minus sign. So I'm going to bring down the 1 minus 2i. And then here, I'm going to bring down the 1. I can combine negative 2i and negative 2i to give me negative 4i. And then over here, remember, when you have an I squared in the expression, isn't I squared equal to negative 1, right? It's equal to negative 1. So what we really have here is positive 4 times negative 1. Well, 4 times negative 1 is just negative 4. All right, so again, I'm going to bring down the 1 minus 2i. And here we could still combine like terms. 1 minus 4 is negative 3. So we have negative 3 minus 4i. Okay, and you know, even if you had multiplied together these 2 parentheses first, you would have the same exact thing. All right, so now I'm just going to double distribute again. So 1 times negative 3 is negative 3. 1 times negative 4i is negative 4i. Negative 2i times negative 3 would be positive 6i. And then negative 2i times negative 4i would be negative 2 times negative 4 is positive 8, and I times I is I squared. All right, so let's see. I'm going to bring down my negative 3. I can combine my like terms. Negative 4i and positive 6i would be positive 2i. And then since I squared is equal to negative 1, positive 8 times negative 1 is negative 8. So I'm going to write minus 8. And then when we combine our like terms, we have a negative 3 and a negative 8, which gives us negative 11. And then plus 2i. So this is my answer. Now I want to point out, because they say to write it in a plus bi form, you want the term with the I second. So if you had written this as 2i minus 11, just reverse the order. It should be negative 11 plus 2i. In number 9, they want us to find the roots. So basically, we're solving the equation, and we're going to write our answer in simplest a plus bi form. Okay, so we have a quadratic here, right? Because our biggest exponent is an x squared. So we're going to jump right into the quadratic formula. All right, so we can see that our a is 4, our b is negative 3, and our c is 6. All right, so let's plug in the numbers here. So we have x equals negative 3 will be positive 3 plus and minus the square root of b squared, so negative 3 in parentheses squared. Remember, if you have a negative, you have to put it in parentheses before you square it. Or you could just write out 9 minus 4 times 4 times 6. And that's all going to be over 2 times 4, right? 2 times a. All right, so that gives us x equals 3 plus and minus. Now let's figure out what this is equal to under the radical. So 9 minus 4 times 6 is negative 87. And that's going to be over 8. All right, now 87, the only perfect square that divides evenly into 87 is 1. So 87 isn't really going to break. I mean, if you want to write radical 1 and radical 87, and then we have to make a third radical for the -1. You can, but the square root of 1 is just 1, so that's not going to change anything, okay? That's basically just 1. And since the square root of -1 is I, this leaves us with, remember, put the I in front of the radical, this leaves us with I radical 87, okay? The reason we put the I in front of the radical is so that it doesn't look like it's under the radical. Okay, so let's come back over here, and we can rewrite this as 3 plus and minus I radical 87 over 8. All right, and since there's a 1 in front of this I, we have a 3, a 1, and an 8. I mean, that's not going to simplify. The only number that divides evenly into all three of those numbers is 1, which doesn't simplify for us. So now we're going to break it up into A plus BI form. So we're going to take what's in front of the plus and minus and put that over 8, and then we're going to take what's after the plus and minus and put that over 8. So we can rewrite this as x equals 3 over 8, and then plus and minus. You could either write I radical 87 over 8, okay, and leave it like that. Sorry, that's a 7. That doesn't really look like a 7. Let me change that. Okay, or if you prefer, you can write 3/8 plus and minus radical 87 over 8 and pull the I to the outside of the fraction. Okay, so either one of these two is fine. In number 10, it's similar to number 9. We also have to write our answer in simplest A plus BI form. All right, well, since I have fractions here, I'm going to take the -2 and put it over 1 to make it into a fraction. Actually, I'm going to rewrite this to give myself a little more room. Okay, so first thing we want to do is we want to find a common denominator. And basically, if it's included in any of the denominators, you want to include it in the common denominator. So x minus 3 will be in our common denominator. X will be in our common denominator. And this 1 you don't really have to worry about because there's technically a 1 in front of the x. Okay, so here we have the x minus 3, but it's missing the x that this other denominator has. So I'm going to put the x in front of that fraction. Now, if I put it in the denominator, I also have to put it up in the numerator. All right, so now we have an x times an x minus 3. All right, let's look at the second fraction. This has the x, but it's missing the x minus 3 that we have in our first denominator, so I'm going to put it down there in the denominator. Notice I'm putting the binomials in parentheses. And if I put it in the denominator, I also have to put it in the numerator. All right, now if we look at our last fraction, it's missing the x, and it's also missing the x minus 3. So we have to put both of that there. We're going to put the x as well as x minus 3. If we put it in the denominator, we have to put it in the numerator. Okay, so now that all of these denominators say the same thing, we can just take them and just cross them right off. Okay, so now I'm going to rewrite the numerator, or the numerators, right? And this is the equation that we're going to be solving. All right, so let's distribute. X times 5x is 5x squared. And then when I distribute the -4, I get -4x plus 12, right? Because a negative times a negative is a positive. And then here, I'm going to distribute the -2x inside the parentheses. So -2x times x is -2x squared. And -2x times -3 is positive 6x. All right, now, because we have x squareds in our equation, we want to get one side of the equation set equal to 0. And I'm going to move these two terms over to the left because I want to have a positive number in front of my x squared term. So in order to do that, I'm going to add 2x squared to both sides of the equation, and you can line up that under the other x squared term. And then I'm going to subtract 6x from both sides of the equation, and also you can line that up under your x term. Okay, so that leaves us with 7x squared minus 10x plus 12. And then on the right-hand side of the equation, everything cancels. So please make sure you write equals 0. Okay, see this equal sign? You have to have an equal sign every step of the way. All right, now here, Because they're saying to write it in simplest a plus bi form, that's kind of cluing me into, ooh, let's not do the rainbow. Let's actually use the quadratic formula, okay? And we can use a quadratic formula because our biggest exponent is a square, okay? This is a quadratic. So I'm just going to go and plug it right in because we wrote out the quadratic formula in the last question. All right, so we have x equals negative b, so negative 10 would be positive 10 plus and minus the square root of negative 10 squared. So negative 10 times negative 10 is 100. I'm just going to write it as 100 this time. If you want to write negative 10 in parentheses and square it, you could do that. And then minus 4 times a, which is 7, times c, which is 12. And that entire thing is going to be over 2 times a, so 2 times 7. Okay, so we have x equals 10 plus and minus. Now you just want to figure out what that's equal to under the radical. And when you do, you get negative 236. And that whole thing is going to be over 14. Okay, now just to remind you, we cannot at this point just simplify the 10 and the 14 because there's a 1 in front of this radical. So we have to simplify this radical first. All right, I'm going to do that off to the side. So we have radical negative 236. Now, since 236 is not a perfect square, I know I need two separate radicals to break that up. And then I need a third radical, right, to take into account this negative 1. So I'll put the negative 1 here. All right, so the biggest perfect square that divides evenly into 236 is 4. And 4 times 59 is 236. Okay, so the square root of 4 is 2. I'm going to jump over here. The square root of negative 1 is I, and then I'll bring down the radical 59. Okay, so this is what I'm going to write instead of radical negative 236. All right, so we have x equals 10 plus and minus 2i radical 59 over 14. Okay, now we could simplify the numbers outside the radical because we have a 10, a 2, and a 14. The biggest number that divides evenly into all of those would be 2. So 10 divided by 2 is 5. 2 divided by 2 is just 1. So you could write 1i if you want, or just I. Okay, I'm going to write I radical 59. Bring that down, right? And then, 14 divided by 2 is 7. Okay, so if we remember the directions, said to write it in simplest a plus bi form. So all we have to do at this point is just, right, break it up so that we individually put the number in front of the plus and minus over the 7, and then what comes after the plus and minus over the 7. All right, so let's do it. X equals 5 over 7, and then you can bring down the plus and minus, and then we're going to have I radical 59 over 7. All right, I'm just going to change this. Okay, sorry, that 5 was pretty bad. Let's see if I can make it a little better. There we go. All right, so this is one way you could write it in a plus bi form. And the other way, if you like to have an a and then a b and the I afterwards, if you prefer that, you could rewrite it as x equals 5/7 plus and minus radical 59 over 7 with the I on the outside. And I know some of you prefer that because then it's clear, like here's my A, here's my B, and here's my I. All right, number 11, determine the zeros. Now, when you want to determine the zeros, all they're telling you is to set this, to set this equal to 0 and solve. So let's do it. All right, now I'm looking, and if you notice, I mean, all of these numbers are even. So if you want to divide both sides of the equation by 2, you can, okay? But also, if you notice, can't we pull out an x squared out of each of these terms? So I want to point something out. Although you could divide an equation by a number, right? Although you could divide both sides of the equation by a number, you don't want to divide by 2x squared. Because if you divide by a variable, see how this exponent, the biggest exponent is a 6? That tells you could have up to 6 answers, right? If you divide by x squared, then you're only going to have x to the 4th, right? You're getting rid of, basically, 2 of these x's, which means you're eliminating some of your answers. So if you want to divide both sides of the equation by 2, you can, but you cannot divide by a variable. What you can do instead is you could factor out that variable. You could factor out the x squared. I'm just going to factor out the 2 along with it, because if I'm factoring out the x squared, I figure you might as well just factor out the 2 as well. So then that's going to leave me with x to the 4th, and then plus x squared, and then minus 72 equals 0. Okay, again, I just want to point out, the reason I factored this out instead of dividing both sides of the equation by 2x squared is because then I would have been left with a 4th degree equation, which would mean the maximum number of answers I could have is 4. And that's not true. The maximum number of answers you could have is 6. So please don't divide by a variable, because it eliminates some of the answers you could have. All right, so now I'm just going to factor further. So I'm going to bring the 2x squared down. And then here, since we have a trinomial where the leading coefficient is 1, I'm just going to set up 2 sets of parentheses. I know some of you try to do the rainbow. You can if you want, but you definitely don't have to. If this leading coefficient is a 1, you can just, it's a one-step factoring. If this is an x to the 4th, we put an x squared here and here. And then we just come up with 2 numbers that add to positive 1 and multiply to negative 72. All right, so that'd be positive 9 and negative 8. Okay, now because this is a plus sign, this is not a difference of perfect squares, so we can't factor further. So I'm going to just jump right into my t-chart. And I'm just going to set each of these factors equal to 0 and solve. All right, so the first one, I want to solve for x. I'm first going to divide both sides of the equation by 2, leaving me with x squared equals 0. And then I'm going to take the square root. So it leaves me with x equals. Now, normally I write plus and minus, right? Because a square tells me I could have 2 answers. But since there's no such thing as positive and negative 0, right? 0 is just 0. It's neutral. I'm just going to write 0. So over here, we could have wound up with 2 answers because of the x squared, but we only wound up with 1. Okay, so here's one of our answers. All right, now, over here I'm going to subtract 9 from both sides of the equation. So I have x squared equals negative 9. And then when I take the square root, this time I have to write plus and minus. Now, some of you could just look at this and say, all right, that's equal to 3i. If not, break it up. Okay, we have radical 9 times radical negative 1. So x equals plus and minus. The square root of 9 is 3, and the square root of negative 1 is I. So here's 2 more answers, positive and negative, 3i. And then finally over here, we're going to add 8 to both sides of the equation, which leaves us with x squared equals 8. And then when we take the square root, we get x equals, and don't forget the plus and minus, because the square tells us we could have 2 answers. Now, radical 8 isn't a perfect square, so I'm going to break that up into radical 4 times radical 2. And since the square root of 4 is 2, it leaves us with plus and minus 2 radical 2. Okay, so altogether, we could have had 6 answers, but we only have 5, right? We have positive 2 radical 2, negative 2 radical 2, positive 3i, negative 3i, and 0. The only reason we have 5 instead of 6 is because there's no such thing as a positive and negative 0. So we wound up with 1 answer here. All right, number 12 says, consider the function. All right, they want us to determine whether x minus 8 is a factor of f of x. I mean, if you want to decide if this is a factor, the long way, which I'm not even going to bother doing, is you could take what f of x is equal to and divide it by x minus 8. And if there's no remainder, then it's a factor. But we learned a shortcut method, right? The shortcut is if x minus 8 is a factor, if you were to take positive 8 and plug it in for all the x's, if it equals 0, then it's a factor. So that's what I'm going to do. I'm going to find f of positive 8. Okay, so what I did was I just replaced positive 8 in for all the x's. And you could just plug this in your calculator. And when you do, look at that, it is equal to 0. F of 8, sorry, I don't know what happened there. F of 8 is equal to 0. So what that tells me is, since f of positive 8 equals 0, x minus 8 is a factor. Okay, so you could say that x minus 8 is a factor because f of positive 8 equals 0. Or another way of saying that is x minus 8 is a factor because x equals positive 8 is a 0. Either way is fine. All right, so part B wants us to determine the zeros of f of x. Now, if you tried to take f of x and factor it by grouping, you would run into a dead end because you would realize that you don't have the same binomial left in each parenthesis. So you have to come up with plan B. Well, we know that if x minus 8 is a factor of f of x, it would divide evenly into f of x. So that's what I'm going to do. I'm going to take f of x and divide it by its factor of x minus 8. Now, one other thing that I want to point out, because x minus 8 is a factor of f of x, right, this will divide evenly into it, so you will not wind up with a remainder. If you wind up with a remainder, it means you made a mistake. You just got to go back and find it. Okay, so let's see. Let's start. You want to look at the first term outside the division bar and the first term under the division bar and say, what do I multiply x by to give me x cubed? Well, I multiply it by x squared, so I'm going to put that right up here. And then I'm going to distribute x squared times x is x cubed. And then x squared times negative 8 is negative 8 x squared. Okay, and we know we have to subtract, so we're going to change our signs and circle, change our signs and circle. Okay, so we have x cubed minus x cubed, right? Those cancel. And then we have negative 7x squared plus 8x squared, which is positive 1x squared. So I'm just going to write x squared, and then I'll bring down my next term. All right, we start the process again. We look at the first term outside the division bar, and then we look at the first term where we left off down here under the division bar, and we say, well, what do I multiply x by to give me x squared? Well, x. So I'm going to put an x up on top. And then x times x is x squared. And x times negative 8 is negative 8x. Okay, and again, we know we have to subtract. So I'm going to change my signs and circle, change my signs and circle. All right, so x squared minus x squared just cancel. And then negative 28x plus 8x would be negative 20x. And then we're going to bring down this last term. So this is our last time we're doing this, and let's hope we don't have a remainder. If we don't, we know we're on the right track. All right, so I want to look at my first term outside the division bar and the first term of where I left off with under the division bar. And I say, well, what do I multiply x by to give me negative 20x? Negative 20. So let's put the negative 20 here. And then negative 20 times x is negative 20x. And negative 20 times negative 8 is positive 160. All right, so this is looking good because now when we go to change our signs and circle, change the sign and circle, what you'll notice is, look at this, everything cancels. And we have no remainder, so that's what we wanted. Now, right now we know that x minus 8 is one factor. And we know that x squared plus x minus 20 is another factor. So I'm going to line them up next to each other as factors, okay? So we have x minus 8 is one of the factors. And we have x squared plus x minus 20 being another factor. Now, it says here that we want to determine the zeros. So basically what we want to do is we want to set this equal to 0. I don't know if I'm going to have room to put it on the right, so I'm just going to put it on the left, which is okay. All right, so now I have 0 equals x minus 8, and I'm just going to factor this factor further. So I want to come up with two numbers that multiply to negative 20 and add to positive 1. So positive 5 and negative 4. So x plus 5 and then x minus 4. And now if we make a t-chart, we wind up getting x equals 8. Okay, that's one of our zeros, which we already knew up here from part A. And then we have x equals negative 5 as our second 0. And then x equals positive 4 as the third and final 0. Okay, if you want to write it in a solution set, you would write your smallest number, and then the next biggest number, and finally the biggest number. You don't have to do what I did here. You could leave it like this if you want. All right, and then finally number 13. So number 13, part A just wants to know what is the remainder when h of x is divided by x plus 1. Okay, if we're dividing by x plus 1, we're going to look at when x equals negative 1. All right, we're going to find h of negative 1. All right, well, let's look at our graph. If we go over to negative 1, you'll see that the graph right here goes through the point negative 1, 0. So what that means is the y value is 0. So h of negative 1 is equal to 0, okay? That's what h of x that's what the remainder would be if h of x is divided by x plus 1. All right, in part B, we're dividing by x minus 1. So we're going to look at when x equals positive 1. All right, we're going to find h of positive 1. All right, so we're going to go over, I'm going to just kind of get rid of this. We're going to go over to positive 1 on the graph, which is right here, and we have to follow it all the way up here, and you'll see, look, it's at a height of, it's a little blurry to see here, but it's at a height of 8. Okay, the coordinates of this point are 1, 8. So the y value, when the x value is 1, is 8, which also means that if we were to divide the function by x minus 1, the remainder would be 8. Okay, letter C. What is the remainder when h of x is divided by x? Now what you'll notice is here, like this one said x plus 1. This one said x minus 1. Technically, if you have an x, isn't that really the same thing as, like, let's say x plus 0, right? Or x minus 0. So really, what we're finding here is h of 0. We're looking for the y value when the x value is 0. So let's see, when the x value is 0, you can see the y value here is 6 because the graph crosses through the point 1, 6. So 6 would be the remainder if we divided by x. All right, now it says in letter D, what is the relative maximum value? Okay, the relative maximum value. Well, if you recall, this down here is a relative min, and this up here is a relative max. It's the highest point in a certain section of the graph, in a particular domain of the graph. And if we want to know the relative maximum value, the value would be the height of it here, which is at 8. Okay, so the relative maximum value is 8. All right, let's see what we have. I'm going to slide this up so it gives me more room. Describe the end behavior. Okay, so we're going to start this off by writing as x approaches negative infinity. So basically, as we go to the left on our graph, what's happening to our function? Is it going up or down? So as we look to the left on our graph, isn't this arrow pointing up? So h of x, make sure you write h of x, not f of x. H of x is approaching positive infinity because it's going up, right? And then this means as x, so we say as x approaches positive infinity. So that means as we go to the right on our graph, so as we're looking to the right on our graph, what are the y values doing? What is h of x approaching? We'll see how this arrow is pointing down. What that means is it's approaching negative infinity. All right, and then finally our last part here. Write an equation